Hi everybody, quick video on taking the weighted average of isotope masses to find the atomic mass of an element. So here's our periodic table. Let me just call your attention to chromium right here. Chromium, Z equals 24. You can see over on the left side that chromium has an atomic mass being listed of 51.996. See that? 51.996. That's the atomic mass of chromiums in general, of all the different chromiums that are out there. And what we know is that there's more than one chromium isotope. In fact, chromium has a whole bunch of isotopes, and if we click on one of them, we can actually find out a little bit about chromium. So let's look at this, and you can see chromium has stable isotopes: chromium 50, chromium 52, chromium 53, chromium 54. And what this is telling us is what percent of all chromiums is each one of those. About 4.35% is chromium 50. Most chromium, 83.789%, is chromium 52. But there's a little bit of chromium 53 and an even smaller amount of chromium 54. So if we want to get the atomic mass of chromiums, which would have that mixture of different isotopes, we need to take an average. But the average we're going to take is not the kind of average where we just add everything up and divide by the number of observations. We're not just going to add up 4 isotopes and divide by 4. And the reason is that they're not there in equal abundance. So where does this 51.996 number come from? Well, let's look at a spreadsheet here. What I have here is the isotopes of chromium in this first column. Those are all my chromiums. I've made them yellow. So chromium 50, 52, 53, and 54. Now it turns out their precise atomic mass is not exactly 50, 52, 53, and 54. Those are their particle counts of protons and neutrons. The precise atomic mass of these is slightly less. Chromium 50 has a precise mass of 49.946. So you can see there's a little bit of an adjustment there we're going to need to make so that we can actually use the actual mass of chromium 50. All right, so what are we doing here? We're taking a weighted average. How do we do that? Well, each of the percents of the percent abundance is going to be the multiplier. So we want to average these 4 different isotopic masses weighted by their abundance. If it was 1/4, 1/4, 1/4, and 1/4, in other words, if all of them were 25%, we could just add these 4 numbers up and divide by 4. But only 4.35% of it is chromium 50. So we're going to use the 0.0435. Now remember, that just comes from converting a percent into a decimal equivalent. So if I say down here, look, 5%, that actually is the same as 0.05, right? And if something is 78%, we know that's the same as 0.78. So we need the converted decimal fraction that each percentage represents. I could take these and just format them into percentages. If I want to see them as percentages, I can do that and say, oh, show them as a percent. Oh yeah, 4.35%, 83.79%, 9.50%, and 2.36%. Let's go back to showing them as decimal fractions. Now, what I need to do to take the weighted average is take this green isotopic mass and multiply it by the percent abundance. So let's make those kind of pink. So 49.94 times 0.0435. That gives me this product, 2.17. See, I've multiplied the isotopic mass times the percent abundance is 2.1727. So I'm going to do that for each one of these 4 isotopes and get their contribution to the overall average. So 2.17, 43.52, 5.03, 1.27, I'm going to take all those 4 and add them up. And when I add them up, what I'm going to get is this number here, 51.996. 51.996. That is the overall average atomic mass of chromiums when they're made up of these 4 isotopes in these 4 abundances. And notice what happens. The periodic table is listing that 51.996 as the overall average atomic mass of chromiums in general. You can see the same thing being done here for magnesium, which only has 3 isotopes, magnesium 24, 25, and 26. And once again, I can see here the percent abundances, and I can change those once again to really show them as a percent. You can see 78.99, 10.00, 11.01. When I multiply the mass, 23.985, by the abundance, 78.9%, I get the contribution to the average. Add those 3 up, I get 24.305. What? 24.305. That's what's on the periodic table. Right, because that's where it comes from. So now your job is to do exactly that for strontium. And here's the strontium homework. So you can see I'm giving you strontium. It's got 4 isotopes. It's also got the precise atomic mass for each of those 4 isotopes and the percent abundance. Now those are percentages. So remember, those need to be converted to a decimal fraction. And 0.56% is less than 1%. It's a half of 1%. So that's going to be 0.0056. This is going to be 0.0986. This is going to be 0.07, and this is going to be 0.8258. So then do your multiplications, add up all 4, and see if you get a value that matches what the periodic table tells us is strontium's atomic mass average. You should get 87.62. Okay, I think that's all for that, and you should be in good shape. We're going to stop there, and good luck.